everyone and welcome back to NotesNaka. Today is day 24 of the lead coding challenge, and for today's problem we have construct binary search tree from preorder traversal. So we will be given a preorder traversal and we have to construct a binary search tree. Now to understand the logic behind this question, let's check it out first on pen and paper. So in today's problem, we will be given an array of pre-order traversal of a tree. So what happens in a pre-order traversal is the root will be visited first, then the left child, then the right child. So what we have to do is form a binary search tree using this pre-order traversal. So if we do that, we will know for sure in pre-order traversal the first one will be root. So we make it the root, and after that all the smaller ones will be on the left and larger ones on the right. This is the property of binary search tree. So we will use that and the pre-order traversal to construct this. Now what happens is we check for 5. It is smaller, so we keep it on the left side. Then we have 1. Now 1 is smaller than 5, so we keep it on this side. And for 7 it is greater than 5, so we keep it on this side. So this is how we will form this tree using the pre-order traversal, meaning that the root will be traversed first, then the left side, then the right side. So how will we use recursion in this? So what we will do is first initially make a root of null. So our root is null. This is our root. Then what we will do is we will traverse this whole list, and for each of the elements we will call a new function which will insert that element at the correct position. So first iteration we will send our null root and our 8. So for this what it will do is we already if the root is null, then it will simply create a new node. It will insert a new node creating a new one and insert this value. So we will now have root as 8. In the next iteration we will send our root, which is 8, our root, and the next element, so 5. For this what it will do is first check if the root is null. If the root is not null, what it will do is it will check the value that we have passed and compare it with the root's value. Since 5 is less than 8, then what it will do is it will insert a new node in the left of root. So root of left will be equal to, call that insert function again for root of left. So root of left is this side and this is null right now. So when we call this function, it will turn out to be the base case, which is root is equal to null, and it will return a new node with this value inserted. So we will have 5 here now. Now what it will do is in our third iteration we will again send our root and the next one, 1. Also it will return the root after finishing every call. So for 1 what it will do, root is not null, so it will check for 1. It will check for 8. Since 8 is greater than 1, it will call for the left one. So it will go to left and this one. This will be sent with 1 now. Now what it will do is it will again check for the value, and 1 is again smaller. So it will again go to the left, and since now it is null, it will insert a new one here. After this what it will happen is we will have our fourth call after the root is returned and we are back in our main function. In the fourth one it will send 7. So we will have root comma 7, and what it will do now is when we send 7 it will check with 8. It is small, so it will come here. So in the else part what will happen, it is greater than 5, so it will insert it in the right side. It will call the function again insert for the right child, and since this is null it will fall in the base case and it will just create a node here with this value. So we have 7 now. Now what happens, we go for 10. For 10 again it checks root is not null and root is smaller than the current value, so it will go to our right side, and since this is null now it will just create a node and insert it there. After that for 12 again it will go here and insert it here. So using recursion we have created this tree very effectively. Now let's check out the code. I hope you got the basic algorithm. Now what we will do is, this is our code. So it is very basic, simple code. We are just using recursion. This is our main function where we first initialize a root to null and then we iterate through each and every element of our preorder, the list that is given to us, the preorder traversal. And what we do is root is equal to insert root comma preorder of I. Now what will happen is we will call a insert function. This is our insert function, and if the root is null, then we just create a new node and insert the value that we have passed, and we pass each and every element in each iteration. And if x is less, then we insert it in the left side, and if the x is greater, then we insert it on the right side, following our VST property. And at the end we just return the root, and we have root at the end. And this whole thing happens for all of the values, and at the end we have our root and we just return the root, and that is our final answer. If we run the code, we can see that our answer and the expected answer is same. And if we submit, you can see I have already submitted, but if I submit again, you can see that it's accepted. So our code is running well. This is our basic recursive code, and I hope you understood this explanation. If you did, then do give us a thumbs up. Also subscribe to our channel, and I'll be back with a new video tomorrow again. Till then, take care and bye bye.